All right, here are the solutions to the 4.5 activity on substitution. All right, the first integral is an indefinite integral. It's the square root of 6x plus 4 with respect to x. The only function inside of another function here is 6x plus 4, so it's our choice for u. du is 6x dx. We only have a dx in our integral, so we multiply by 1/6 on both sides there. And then we can rewrite that integral as 1/6 the antiderivative of u to the 1/2. We can take that antiderivative on doing the power rule. And then we remember that this question was asked in terms of the variable x. And so our expression for u gets rewritten in terms of x here to finish. Okay, so our second example is another indefinite integral. It's x cosine of x squared plus 1. Again, the only function going into another function here is x squared plus 1 going into the function cosine. So the derivative of x squared plus 1 is 2x. We have an x dx. We can rewrite the integral. We see that we have an x dx to work with. So since du is 2x dx, we'll multiply by 1/2. And so we get cosine of u times 1/2 du. The 1/2 can come out in front of the integral. The antiderivative of cosine is sine of u. But then again, we finish by going back to the variable x. Okay, here, this one looks tricky because of the square roots, but we can handle it. So again, there's a function being squared in the denominator, 1 plus root x. So it's the right choice for u to start because it's inside of another function. So u is 1 plus root x. I can take that derivative. The derivative of 1 is 0. The derivative of x to the 1/2 is 1/2 x to the negative 1/2. So I'll rewrite du. It's 1 over 2 root x. Now I'm going to rewrite the integral. I'm going to break this fraction up into multiplication. I can rewrite this as the multiplication of 1 over 1 plus root x squared times 1 over root x. If I multiply those things, I multiply numerator and denominator, I get exactly what's inside the integral. And so here's the piece that I have to work with. And here is du. So they're close. There's just a 2 in the denominator of my current expression for du. So I multiply both sides by 2. And that piece, 1 over root x dx, becomes 2 copies of du. And the first piece is 1 over u squared. So I get the integral of 1 over u squared times 2 du. Again, the 2 comes out. I can take the antiderivative, and it looks like I lost a 2 there. So let me fix that. This should be, let's see, we go to 1 more power is the negative 1 power. We multiply by negative 1, so this should be negative 2. The 2 should have come along, which then would change this numerator to a 2, and then would change this numerator to a 2. All right, glad I caught that one. All right, let's see. There's a couple of definite integrals here to think about. So I did the first 2. I thought we could walk through the last one together. So let's evaluate the integral from 0 to 1 of x cubed times 1 plus 8x to the 4th to the negative 1/2. Again, going into another function, into the square, negative 1/2 power is 1 plus 8x to the 4th. We have an x cubed to work with, which is nice, but when we take the derivative, we have 32x cubes. So here we multiply by 1/32. And then as I suggested in the introduction activity, always change our limits of integration. So when x is 0, u is 1 plus 0 or 1, and when x is 1, u is 1 plus 8 or 9. So my new limits of integration are a new lower limit of 1 and a new upper limit of 9. And when I make the substitution, the 1/32 comes out in front. I get 1/32, the integral from 1 to 9 of u to the negative 1/2. Add 1 to negative 1/2 is u to the 1/2 power, so then I need to multiply by 2. So I get 1/16. And I'm just going to evaluate u to the negative 1/2 from 1 to 9. I get 3 minus 1, which is 2. 2/16 is 1 over 8. All right, this next example looks pretty much like one of the ones on the activity, except the thing being squared here, or sorry, on the introduction, except the function being squared here is sine of t. So it's going to be our choice for u. du is cosine t dt, which I have there, which is great. So now I change my limits of integration. When t is 0, u is sine of 0 or 0. And when t is pi over 4, u is root 2 over 2. And now this boils down to this integral that we should be able to handle pretty easily, and it actually simplifies to root 2 over 12. Okay, last one here. Again, this looks similar to the one above, except the root x, the 1 plus root x squared has been moved to the numerator in this case. But again, the only thing going into another function here is 1 plus root x. And so du, as it was above, is 1 over 2 root x dx. And again, we're going to rewrite this as the integral from 1 to 4 of 1 plus root x squared times 1 over root x dx. So that's not calculus, that's just rearranging the terms in the integral. And so I see I want to match this 1 over root x dx, which means I need to get the 2 out of the denominator over here. So I need 2 copies of du is 1 over root x dx. Okay, so this is 2 copies of du. This is u, so now I just need to change my limits. So the lower limit is when x is 1. U is 1 plus root, oh man, it happens every time, it's crazy. U is 1 plus root 1, or 2. And the new upper limit is when x is 4. U is 1 plus root 4, which is 3. So this now becomes the integral from 2 to 3. The 2 du, the 2 can come out front, and I just have u squared du. But now because I've changed those limits, I can finish this integral in terms of u. So I get 2 times u cubed over 3, evaluated from 2 to 3. Or let's see, the 2/3 is just a constant, it can come out. I can evaluate u cubed at 3, 3 cubed is 27, and u cubed at 2 is 8. 27 minus 8 is 19, 19 times 2 is 38, so 38/3. Okay, there are the solutions to the 4.5 activity. See if you can use those to do the 4.5 homework.